In this video, I am going to solve the problem 34th from chapter 16, Waves Part 1. A string has mass 2 gram and wave speed 120 meter per second and tension 7 Newton. So you have a string and that string mass is given in terms of gram. So we have to convert it to kilogram. And the wave speed is given as 120 meter per second and the tension applied over the string is 7 Newton. So better we can write what is given first, then we can go for getting the answer for part A and part B. Okay, so first one is mass. Its mass is 2 gram. So converting the gram to kilogram is just multiply with 10 power minus 3 kilogram, and the wave speed V is equal to 120 meter per second, and the tension is 7 Newton, right? Now, by using these values, what we are going to find in the first part, we are going to find what is the length of the string. It's very easy, as we know the relation for the speed of the wave over the string, which is given by the rule V, which is equal to square root of T over mu, right? Clear? And here, this mu is nothing but mass per unit length, right? If you take the value of the mu, if you substitute here, the equation will become V, which is equal to square root of T over mass per length, and this L will go to the top. By that, the equation will become V equal to square root of TL over M, right? Now we are going to find the value of this length. So I have to discard the square root. So what I am going to do, I am going to squaring this equation both left hand side and the right hand side. So if you're squaring left hand side and right hand side, what will happen? The left hand side of the equation becomes V square, right? And the right hand side, the square root will go on. By that, the equation will become TL over mass, right? Okay. Now we are going to find the length. So once again, you have to rearrange this equation in terms of length. Therefore, the length equation is equal to this M will come to the numerator of the left hand side and this T will come to the left hand side of the denominator. By that, the equation will become L is equal to M multiplied by V square over T. So we have all the values. So first of all, I am going to see what are the values we have. So I think this is our first question. So better I can write A here. So mass is 2 gram and V is 120 and T is 7 Newton. So I'm going to substitute the value here. So the mass is 2 grams. So we have to convert it to kilograms. So 2 multiplied by 10 power minus 3. And the speed is 120. So I have to squaring this number. And the tension we applied here is 7 Newton. So now I have to calculate what is the value of the length, right? So 2 multiplied by 10 power minus 3 multiplied by 120 square, which is speed, over 7, which is tension. I got the answer as 4.114. So I can write 4.11 meter. So this is the answer for the first question. Clear? Okay. And we have one more question. So we have to read what is given in the question. What is the lowest resonant frequency of this string? As we already solved one question in the previous video, whenever you come across this word lowest resonant frequency, we have to consider the end value, which is equal to 1. All the times, the lowest resonant frequency is always n is equal to 1. Clear? As we already know the rule for the frequency, the general formula for the frequency is given by the rule f, which is equal to f of n, which is equal to nv over 2l, right? So here, the lowest possible frequency, the resonant frequency is n is equal to 1. So now I'm going to substitute the value here. So f of 1, which is equal to 1 multiplied by, and speed they already mentioned in the question as 120, right? Divided by 2 multiplied by the length value. I'm going to take it from the first part, which is 4.11. So now I'm going to calculate the frequency for n is equal to 1. So 120 over 2 multiplied by 4.11, I got the answer as 14.598. So I can write as 14.6 hertz or 1 over second. Clear? So this is the answer for the second question. Thank you.